Matter is the stuff that the universe is made of. It has mass and it takes up space. On Earth, the three most common states of matter are solid, liquid, and gas. In space, the most common state of matter is plasma.
The states of matter help us understand the nature of the particles of matter. The characteristics of the particles, atoms, or molecules determine the state of matter. Each state of matter has different properties.
Matter in a solid state has definite volume and definite shape. If you move it, it will not change its shape. Its particles are closely locked together and vibrating in place. Density is a measure of how compact the particles are. A solid state has the greatest density since the particles are so close together. Two ways that you can change the state of matter is by changing the temperature or by changing the amount of pressure. In this demonstration, we will be keeping the pressure constant at 1 atmosphere and we'll be changing the temperature. This thermometer will measure the temperature in Celsius. When we add heat to a solid, at a certain point, it turns to a liquid. This is the melting point. The particles of a liquid slide past each other and move over larger distances. Liquid still has a definite volume, but no definite shape. Liquid will take the form of whatever container it is placed in. The freezing point is the same temperature and the point at which the particles inside a liquid condense and change into a solid.
When we add heat to a liquid, it becomes a gas. This is the boiling point. The opposite of the boiling point is condensation. Condensation is the process where water vapor becomes liquid. The particles in gas are constantly moving and bumping into each other. Gas has no definite volume and no definite shape. It is less dense than the other states of matter.
Matter will become plasma when a gas is heated up to at least 3,000 degrees Kelvin. Plasma is usually found in the sun and stars. In an atom of plasma, most or all of the electrons are stripped from the atom. Ions and electrons in plasma roam around.
Plasma is the fourth and most energetic state of matter. It is also the most common state of matter in space.
The Aurora Borealis, or the northern lights, are shafts of colored light visible on occasion in the night sky. This phenomenon starts when solar activity on the surface of the sun ejects a cloud of plasma, coronal mass ejection. One of these clouds may happen to travel to Earth, taking about 2 to 3 days. The particles give off some of their energy to atoms and molecules of gases in the upper atmosphere. But the atoms and molecules cannot hold the energy. They quickly give it off as another kind of energy, the colors of the light that we call the aurora.
On the other side of the energy spectrum, there is a fifth state of matter called the Bose-Einstein condensate.
In July 2018, an experiment aboard the ISS cooled a cloud of rubidium atoms to a 10 millionth of a degree above absolute zero, producing a Bose-Einstein condensate in space.
This state of matter is the opposite of plasma because it only happens near absolute zero. In this state of matter, clouds of atoms act like a wave and appear to be one superatom. This is done in space because gravity interferes with the observation of the experiment.
In 2018, scientists reported the discovery of a Sub-Glacial lake on Mars.
While looking at planets that might be habitable for humans, water is a key factor to consider. This is where the states of matter come in. The low temperature of Mars is connected to the thin atmosphere of Mars. Both these features mean that the water on Mars can only be in two forms, solid ice and gaseous vapor.
Low pressures and low temperature does not allow the water on Mars to take the form of a liquid.
Scientists believe that 4 billion years ago, water was present on the surface of Mars in a liquid state.
Geological evidence shows that the landmarks on Mars were caused by flooding, liquid water.
Due to the water on Mars only being present in a solid state, if we were to live on Mars, we would have to melt the water in order to use it. One job that includes dealing with the states of matter in space is an astrophysicist. Astrophysicists have to have at least a master's degree in engineering, physics, astronomy, or other science courses. It takes 9 to 14 years to complete a bachelor's degree and a PhD, with a major in astrophysics or a similar field.
Astrophysicists are so astronomically cool because they study all of the awesome parts of space, like planets, galaxies, stars, black holes, asteroids, and other celestial bodies, like pulsars, which are dead stars. Some of the more interesting things astrophysicists do are develop astrophysical theories and implement research techniques to test those theories, analyze and develop programs and tools to improve their research, staying up to date with the latest research in the field, and contributing data and research to the field.